All right, so today we're talking about factors and multiples of whole numbers, 3.1. And a few important things. We want to get some definitions understood and talk about factors and products. So in the first example here, I have 3 times 4 equals 12. This is a multiplication math statement, and the 3 and the 4 are both factors. So two numbers that are multiplied together to give you another number, those two numbers are called factors. So you're going to learn today about how to take a number and break it down into its factors. You probably already know this. I mean, when you do your multiplication facts, 3 times 4 is 12. You know that 12 is the result when you multiply 3 and 4. So these are called factors, okay? So I'll be using that term from now on. These are factors. There could be more than 2 factors for a number, which we'll talk about later, but for example, I could do 3 times 2 times 2. That also equals 12, and all 3 of these numbers are factors, okay? So there could be more than 2 factors. There's not usually there isn't just one, because you have to multiply 2 things together, okay? Anyways, the product is the result when you multiply, so that's what I will call that. So the factors for 12 are, like I say, there are whole number factors and there are prime number factors, which we'll talk about. But all the factors of 12 would be 1 is a factor. 1's a factor of any number. 2 is a factor. 3 is a factor. 4 is a factor. 6 is a factor. And 12 is also a factor of 12. Okay? Now, what's kind of neat about this is that when you list the factors from smallest to largest, you should have a connection between the first number and the last number, and then the second number and the second last number, and then all the numbers that pair up like this. So there should be a connection. And that connection is when you multiply them, it should equal the number that you're factoring. So 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And there's no other whole numbers in between 3 and 4, so we know that we're not missing any. Okay? All right, what about for 48? We could do the same thing for 48. And I would encourage you to kind of do this sort of bookend idea, work from the outsides in. So 1 and 48. 48 is obviously a factor of 48, and so is 1. Now, when we start breaking this down, just basically start dividing, right? Dividing this number by different numbers and see what you get. So does 48 divide evenly by 2?
Yes.
Yeah, it does. So we'll write a 2 down there. And what's the number you multiply 2 times? 24. Very good. Okay, so this is how I'm starting to make my list of factors. 1 times 48 is 48. 2 times 24. Is there a 3?
Mrs. Walker, please come to the
Okay.
reception office.
What's 48 divided by 3?
16.
16. Very good. Okay, so 16 is a factor there as well. Okay, what about 4?
Yes.
Yeah, 4 and 12. Okay. Now, the numbers are starting to get closer to one another. That's the idea, right? They're far apart. 1 and 48 are far apart, and then 2 and 24 are a little closer. 3 and 16 a little closer. 4 and 12 a little closer. So what about 5? Is 5 a factor? No, it doesn't divide evenly by 5. And you might remember some divisibility rules. If this ends in a 0 or a 5, it's divisible by 5, but if it doesn't, it's not. So what about 6? Yeah. 6 times 8 is 48, okay? Now, because 7 is the only number in between here, it could be that 7 times 7, we could consider, but 7 times 7 is 49. It's not 48. So this looks like the list of factors for 48, okay? The numbers that when you multiply a pair of them together, it equals 48. Okay, good? What about 30? Let's do the same thing. 1 and 30 I'll put in here. Does 30 divide evenly by 2? Yep. 15, very good. What about 3?
10.
Yep, 10. What about 4? No. 5? Yeah, 5 and 6. And they're right next to each other, so you're pretty confident your list is complete. Okay? And again, if you want to get on your calculator to double check some things, I don't mind, because when the numbers get bigger, like 158 or whatever, you might need your calculator, I guess, but I'm going to show you also another method for factoring that's going to help a lot too. All right, let's talk about prime numbers. Do you know what a prime number is? Anybody? Yeah? What's a prime number? A number that, let's fill in these blanks. A number that only has
2.
Yes, 2 factors, that's correct. So it only has 2 factors, and those are
1 and itself.
1 and itself. Very good. So what are some prime numbers? Let's list some. 2 is the first one.
2,
3, yeah, is 1. What about 4?
5,
No, not 4, because it has 2 and 2, right? So 5,
7,
7.
13.
Okay, and so not 9, not 10, but what about 11? Yeah, 11, I'm gonna miss 11. So 12 has more than, 13?
Yeah.
13, good. 17, not 18, what about 19? Yeah, 19, there's lots actually there's a lot. Okay, so 20 is not, 21 is not, that's 3 times 7, 22, 2 times 11, 23,
Yeah.
okay, prime, good. And then 27?
No, 3 times 9.
24, yeah, 3 times 9 is 27. So 24, 25, 26, 27, 28. What about 29? Okay, 29. All right, and there's more, but we'll stop there. So every number can be reduced, and the reason why we're exploring prime numbers today is because every number can be reduced to factors, and this is part of your notes, so you should be writing this down and kind of filling this out for you, but every number can be reduced to factors that are prime numbers. So that's an important note there. Make sure you have that in your notes. What is a prime number, and the fact that every number can be reduced to factors that are prime numbers. So we see this list of prime numbers, and you might, in the list of prime factors, you might have to list a prime factor more than once. So that's possible. So 10, we're not going to count 1, we're just going to start with 2. So is 10 evenly divisible by 2?
Yeah.
Yeah.
5.
And it's 5, okay, so we've got 5, that's a prime number, so I'll write that down. Any other factors there that are prime of 10? Okay, so that's the list of prime factors. It's only 2, that's good. What about 12? So 2 is 1, right? What about, okay, so 2 times 6. Now, we wouldn't write down 6, would we? Because that's not prime. But if you think about it, because 6 is prime, I can split up 6 into 2 and 3. Now I have all primes. So every number can be split into factors of prime numbers. So 2 times 2 times 3 is 12. So there's your list of prime factors.
Combination of those.
Sorry?
And then any combination of those, right?
Yeah, I mean, you can list it in different order. Yeah. Okay, what about 68? So it's divisible by 2. Okay. So you might want to say, okay, well, what are the factors of 68? You might want to list them on the side. You can, I'll show you, actually, you know what, maybe I'll come back to this because, I'll come back to this one because when the numbers get bigger, there's a better way to do this, and maybe you've seen this before. I'm not sure if this is the first time you've seen this, but let's leave this list. We'll come back to it because there's a quicker way than just listing all of the factors and then breaking those factors into prime numbers, which you could do. But let's talk about prime factorization. Okay, so what's an easy way to do prime factorization? And we're going to do this for all 3 numbers. We've already done 10 and we've done 12, but this is going to be a helpful process for you when the numbers get bigger. So you write the number down like this, and then this is what you do. You draw a little, it's kind of like a dividing sign, but it's kind of an upside down dividing sign. It's like a little L underneath the number. And you can divide 10 by 2, and you put the smallest prime factor that you can divide by on the side there. And then 10 divided by 2, you put the quotient, or what that equals, under here. Now, you keep doing this until you get a prime number that's also underneath the original number. And so here's where we stop. So our prime factors are 2 and 5. Pretty easy, right? All right, what about the next one? So 12, can it divide by 2? Yes. So here's where you put the 6. So 12 divided by 2 is 6. Now we do this process again. Can 6 be divided by 2? Start small, yeah. And what's the result when you do 6 divided by 2? 3. So because we have a prime number in this position right here, then I can stop, and 2 times 2 times 3, those are the prime factors. The list is 2, 2, and 3. And that's what we came up with here before, right? 2, 2, and 3? All right. Okay, what about 68? So here's where this becomes really handy. And again, divide by 2 as many times as possible. So 68 divided by 2 gives us 34. Can I divide this one by 2?
Yes.
I sure can.
17.
17. Ooh. Is 17 one of our... Oh, look at this. So because I've stopped at 17 here, I can't split 17 up into any more prime factors. It would just be 1 and 17, right? And I could do that indefinitely, so that's why I don't use 1, because this would go on forever. So when you get to a prime factor, you can just stop. Does that make sense? So the list of prime factors is not that long for 68, but it's 2, 2, and 17, right? 2, 2, and 17. All right. And there's an easy way to do that, and that's this prime factor method. Okay? So why don't you guys do one on your own? Whoops. Hello. The computer's lagging a bit. Oh, stop now. Pause. All right. Do this one on your own. Do like 96. So split 96 into prime factors. Okay? Try that one on your own. Okay, so when you're done your list, look up here and see if your list agrees with mine. I'm just going to check. I'm just going to double check to make sure you make any mistakes. So what you can do is take that list of prime factors that you got. So again, over here on the side, I've got 2, 2, 2, 2, 2, and times 3. Now, I don't know if you guys know this, but when you have 2 multiplied by itself 5 times, you can literally write that in exponential form like that. You guys know that? Cool. So you can do it the long way or the short way. Let me quit here. Okay. So 2 times 2 times 2 times 2 times 2. That's 5 times. Times 3. Let's see what that equals. Oh, good. 96. 2 to the power of 5 times 3 is 96. Okay. So that checks out. So your list of factors, if you're just asking to list them, would be 2, 2, 2, comma, and separate them by commas. Okay? That's the list of prime factors of 96. And you can write it as a multiplication statement there as well. So that's true. Okay, everybody got that? Understand? Okay, let's talk about factor trees. Let's talk about factor trees. So we'll do the same 3 numbers as we did earlier. A factor tree, you know what a tree looks like? It kind of has a pointy top, and then it kind of fans out, right? Like a Christmas tree. Think about a Christmas tree. That's kind of the idea here. And so if you start with 10 and you split this into 2 parts, we're going to try and pick a prime factor if we can. And that's going to be 2, okay, and 5. And then when we end up with a prime factor, similar to the other method, I don't know what you call this, like a ladder method or something. I'm not sure. I don't know if this is the ladder method, or I think I've heard of it called the ladder method. Kind of looks like a ladder, I guess, with rungs, right? This is the tree. So let's do 12. Let's go 3 and 4. And then the 4, now you work on the 4, you see, and you go down from the 4. And that's 2 times 2. When you get to a prime number here, you're done. That's kind of the tree method. Same with 68. 2 and 2 and 34, yep. And then 2 and 17. Done. Okay? So what you have to do is you have to kind of look at the tips of the branches. So this is the end of a branch, this is the end of a branch, this is the end of a branch. That's how you identify your prime factors here. Okay? So you wouldn't circle this one because it's not the end of a branch. Does that make sense? And you wouldn't identify that one either. Okay, so that's a factor tree. All right. All right, moving on. What is the GCF? Do you know what that stands for? Greatest common factor. That's true. So GCF is the greatest common factor. Okay, so the greatest common factor is literally just that. It's pretty self-explanatory. It's the largest number that is a common factor to two or more numbers. So what's the greatest common factor of 28 and 42? This is going to be an important skill because, partly because when you add and subtract fractions and different things like that. So the greatest common factor, you can just start listing the factors if you want. 1 and 28, right? We've got 2 and 2 and 14. Come on, computer. 2 and 14. 3. No, 4. 4 and 7, right? Okay, 5 and 6 is in between 7. Nope. So this is our list. Okay. Factors of 42. 1 and 42. 2 and 21. What about 3? Yeah. So 3 times 13 would be 39, yeah. So 3 times 14. Okay. Numbers in between there? Not 4? Where's 4? Is 4 1? Okay. No, so then 6 and 7, right? So again, it might be easier to work up from the bottom to make your list. Okay, so what's our greatest common factor? The largest one that's common. Now 2 is a lowest common factor, but greatest common factor is 14, you see that? So 14 is the GCF here for 28 and 42. Okay. Now you can list the factors like that and identify the largest number, which some of you might go for. There is a prime factor method. So if you can kind of get a handle on this one's a bit tricky to remember, but if you can use this one and remember this one, it oftentimes for larger numbers will be a little bit easier than listing out all the factors. So the prime factor method, what you do is you take each number and you separate it into its prime factors. So there's a 2 and 14, 2 and 7, okay? So, done. And then 42, 2 and 21, 3 and 7, okay? So those are the prime factors of 42. So what you do is you look for all common factors and circle them. So the common factors here, I'll circle 2 is a common factor, and 7 is a common factor. So the greatest common factor for these two numbers would be 2 times 7. So the numbers that are common to both lists, or both sort of prime factor lists, you multiply those together and 14 is your common factor. So that's maybe a little not quite as intuitive as just listing the factors and looking for the one that's the same, that's the biggest. But this works really well too, especially if you already have prime factors, because they're useful for other things too. Okay, all right, so let's find the greatest common factor of these 3 numbers. And here's where this ladder method, noticing the common prime factors, is really going to be handy, because this would be a long time to list all the factors for really large numbers. So let's go through this. Let's divide by 2, and I get 60. Divide by 2 again, I get 30. Divide by 2 again, 15. 3, 5. Done. Run into a 5. Looks like I'm done. All right, 2 is what?
380.
480 maybe?
Yeah, 480.
So 480. Okay, 2 is 240. 2 again, 120. 2 again, 60. Oh, and look at, now the list gets the same as over here. So 2, 30, 2, 15, 3, 5. Okay, that's great. 1400, let's divide that by 2. 700. Divide that by, okay, well, it's an even number, so we can do 2 again. 350. Okay, is that an even number? Can we divide it by 2? Should be able to. What's 350 divided by 2? Sorry? One, yeah, 175. If you think about 35 divided by 2, that's 17.5. So 350 divided by 2 would be 175. Okay. Now, this one doesn't look like we can divide by 2, right? Because it's an odd number. Now, you don't have to, yeah, you don't have to always go to the lowest one here, whichever one sort of pops up. Now, I don't know about 3. Does 3 work with that one? Well, 5 would work for sure, right? So let's go to 5. Okay, so 175 divided by 5. Okay, 35, yeah. And again, if you have to use your calculator for this, that's fine. So 35, yeah, 170, so 35 times 5, right? 5 times 30 is 150, and then 5 times 5 is 25, so there's your 175. Okay, awesome. So 35, where am I at here? Yeah. Okay, and 35, that can be divided by 2, 3, 5, 5, 7. Ah, so I hit a prime factor, so I'm done. All right, so what is common to all 3? So we have to look at what's common to all 3, and that would be 2, another 2, another 2, 3, nope, another 2, nope, 5, yeah, 5. So anything else? No, missing a 3 here, missing another 5 over here. Okay, so it looks like those are the ones that are common. So just take one list, right? Those 3 in that one. So 2 times 2 times 2 times 5, which is what? 40? 2 cubed is 8 times 5 is 40. All right, let's see how we did. Ooh, look at that. 40 is our greatest common factor. So I don't know if this is easier or less time consuming than listing all the factors. I think it would be. Instead of, you'd have quite a list of factors for 1400. But anyways. Okay, so why don't you guys go ahead and do this one on your own. Okay, your turn. Find the greatest common factor of these two numbers, 81 and 216. Go ahead. Let's show your work. Show your work. All right, so prime factor method there. Get it down to prime factors. Circle the ones that are common to both. Highlight the ones that are common to both, and then just multiply those ones you highlighted together. 27. All right. Any questions? Not always will your common factors show up on the list. Notice here that I have 27 here and 27 here. It's not always going to be like that. Because this example right here, 40, didn't show up in any of the lists. But yet that's our common, greatest common factor. Okay? So it doesn't have to show up in the list. All right. Let me just see here. I'm not sure if we're going to split this up into 2 sections or not for now. All right, so we have full class today, so keep going with this lesson. You can always find a common multiple by multiplying the numbers. This is a little aside. So a common multiple, first of all, what is a multiple? What's a multiple? Multiple of a number. Anybody know? It's kind of like factors, but it's not. Factors are what you multiply together to get the number. Multiples of a number are that number sort of times 1, then times 2, times 3, times 4, times 5. So a multiple of a number would be the number times 1, that's the first multiple itself, and then times 2, that's the next one, and then times 3, and so on, okay, etc., so on. So multiples of a number, for example, the multiples of 12 and 14, okay, they would be 12, that's 12 times 1. Then 12 times 2 is 24. And 12 times 3 is 36. And then 48. and then 60, and so on, right? Those are the multiples. So multiples are always bigger, okay? And you can put that in your notes here too, I would say. They're always same or bigger than the number. Okay? They're always the same or bigger than the number. These would be good notes for you guys to write down. I don't see very many of you writing this down. What we're interested in is the least common multiple a lot of times. The least common multiple. The greatest common multiple is not very useful for us. The least common multiple is useful. A lot of times when we're adding and subtracting fractions and things like that, right? You want a common multiple. So the multiples for 12 listed are like this. The multiples for 14 listed would be something like this. 14, then 28, then what? 42, then 56, then 70. All right. So a least common multiple, do we run into a number that's the same here so far, or do we have to keep going? So we haven't run into a least common multiple yet, and so we might be doing this for a while. This is how you use the prime factoring method to do this. So what you do is you prime factor the 12 and the 14, and then you highlight the greatest power of each prime factor in the list. So let me just give you an example here. Okay, so let's break 12 down. Those are going to be 2, 6, 2, 3. And then if we break 14 down, now it seems counterintuitive because we're finding factors and we want multiples, but it'll work out. So 14, 2, and 7. So now what it says is highlight the greatest power of each prime factor in any list. So with the 2's, we have a squared in this list. So we have a 2 squared. The 3's, we have a 3 to the power of 1. Or just 3. And we have a 7, or a 1, 7 to the power of 1. So when you highlight the largest, the greatest power of each prime factor in the list, and you multiply them, what do you get here? This is 4 times 3 times 7. So what's that? 4 times 21, 84. Look like 84. Okay, so 84, if we would have kept going on our list, I get 72 and then 84. Over here, 84 is the very next one. So, yeah. So you can, so two different ways of doing it. So 84 is the lowest common multiple, and you can find that using your prime factors. So prime factorization is pretty handy for a few different things. This one's a bit tricky to remember as well, though. So you should make sure you jot this down. Okay. So to find, here's your sentence if you're looking for one. To find lowest common multiple for 2 or more numbers, so highlight the greatest power of each prime factor in any list, then you multiply them all together. So just the greatest power. So if you had 2 squared in one and then you had 2 cubed in another, you wouldn't do the 2 squared, you leave that one alone, and you just take the 2 cubed if that's the largest one. Okay? So what do we use the lowest common multiple for? For adding and subtracting fractions. So remember what I said earlier, I mentioned that you can get a common multiple by multiplying the two numbers together. That is a common multiple, because you're taking 14 times 16, and then you're taking 16 14 times. So you will get the same number. But it's often not very handy to add and subtract fractions. So you want the lowest common multiple, because we are always looking for lowest or a common denominator when we add or subtract fractions. So let's do this one from scratch. I'll try and delete this so I don't spoil the suspense for you. Okay, so we're going to take the, write this down as an example, 2 over 14 plus 9 over 16. Now, if you notice that 2 over 14 can be reduced, you can reduce that first, that's fine. It's going to be 1 over 7, right? So you could do that first. You wouldn't need to. So let's try. Fire alarm, eh? Bye. All right, so prime factorization. Sam. Prime factorization. Let's just do this. So 2, 7, 2, 8, 2, 4, 2, 2. Okay, so we'll need a common denominator here. So the lowest common multiple will be our common denominator. So I take we have a 2, which the largest grouping of 2 is in this list. Okay, and then the only other prime factor we have is a 7, and the largest grouping of a 7 is in this list. So the lowest common multiple is 2 to the power of 4 times 7. Does that make sense?
Yeah.
So 2 to the power of 4 is what?
16.
That's 16 times 7. So 70 and 42 is what? Was that 112? Okay. So is that 112? 16 and 7, right?
Yep.
So 112 is your lowest common multiple. Now, how you get the numbers on top, again, so 16 times what is 112? So you got to figure that out. Right? So 16 times what's 112? What did we just say? It's this one here, right? 7. So this has got to be 9 times 7, 663. 14 times what gives us 112?
2 to the 4.
8? Yeah, 8. So this is 16. So then our answer then is 79 over 112. So you can use you can use that prime factors to find the lowest common multiple to use for adding and subtracting fractions as well. Okay, any questions? All right. Now I think for 3.1, I think that's all that's in the lesson there. So here's this is split into parts. The the lowest common multiple stuff is in the second part.
Through? Did you get to do s'mores or anything? Or?
No. Thank you. Awesome. Thank you very much.